Hello everybody. This is Unit 2, Day 1. If you are watching this, that means you have successfully made it through Unit 1. Congratulations. All right, give yourselves a pat on the back. All right, nice work. All right, now we're going to be talking about functions. All right, and so before we talk about functions in this unit, we have to first review what a function is. Okay, so I got a list of a bunch of terms here, all right, a bunch of terminology. I'll let you guys read that on your own. Okay, some of this stuff may seem familiar, some of it may not be. All right, but I really want to emphasize on this portion right here, where it says a function is a relation in which no input values are used more than once. Okay, well, what does that mean? Well, input values are your x values or your independent variables. Right? And so what that means is we are not, no input values are being used more than once. All right? So you can't have an x value have an output of both 2 and -2. Okay? If you do, that means that what we're looking at is not a function. All right? So x values or your independent variables can only have one output. Okay? So it's important to make note of that. And also, sometimes, they don't give you, or depending on what they give you, sometimes they will just give you a picture of a graph and say, hey, is this a function? So hopefully some of you guys remember this one, the VLT, all right, vertical line test. If you can draw a vertical line through a graph and hit a relation's points more than once, the relation is not a function. All right? And so let's demonstrate what it is these guys are talking about. Okay? So example 1, so state whether the following are functions, and then state the domain and range. Okay, let me zero in here so I find myself some room here. So as you can see, all right, I'm going to just pretend that's a 4, I guess. I must have got caught off. All right, but as you can see, this input, right, because this is your input, this is your output, okay, we have an input value that has 2 outputs, right? That's what those arrows represent. So therefore, this guy is not a function. All right? We can still talk about the domain and range. So in this case here, okay, because we don't have any numbers in between, right, I'm going to put these in a list. So my domain is just whatever numbers I have in my inputs, and my range is just whatever numbers I have in my outputs. And I put it as a list because I don't want any pieces in between. All right, I'm just talking about those particular numbers, and I'll emphasize what I'm talking about when we go to some further problems. All right, so this one's not a function, and our domain and range is our x and our y values. All right, let's look at B. B. All right, so what we're looking for whether or not we have any repeated x values. So I take a look at these guys right here, and as you can see, they're all different. All right, so we do have a function. And also, what's our domain? Well, it's all of our x values. So I see a 1, I see a 0, -1, -2. And our range is just the y value. So I see a 1 and a 3, right? Now, would it be wrong if I wrote 1 in there 2 other times? No, right? Because we do have 4 outputs there, but it's kind of deemed unnecessary, right? Because a 1's a 1, and so it's just a 1, right? So we only need to write it once. All right, let's look at C. Okay, letter C, we're looking for repeated x values. So I'm looking at these guys. I don't see anything, so this is also a function. Okay, so let's talk about the domain. Well, the domain, right, again, is just these 4 numbers, so I'm going to put it in a list. And down here, oops, almost wrote 8 twice, which wouldn't be wrong, but we don't need to, because an 8's an 8. All right, so there's our domain. There's our range, and this is a function because we don't have any repeated x values. Okay, let's go check out letter D. Letter D looks a little funky, right? Okay. So we're talking about child and birth. All right, so our input is that guy, and our output is birth month. Okay, so let's think about this. So I was born in April. So therefore, I'm only born in April. Right? It wouldn't make sense to be born in April in January. Right? You can't be born twice. Okay? So our input is who you are, right? Your child. And I guess I'm considered a child, right? And your output is your month. All right, and so no matter what you put in there, so if I put, Mr. Fee or Miss Ralston, right? Those guys only have one birth month. Not too sure what it is, okay? But they're only, their input, right? You remember your input is just the person, and your output is the birth month. So therefore, we have a function here, okay? Because you can't be born twice. All right, now, what is our domain? Our domain is just the children, right? Whoever we put in there. All right, so in this case, I kind of made this up, so I guess my domain here would be what? It would be Mr. Kaya, Mr. Fee, and Miss Ralston. Right? Our range, however, okay, would have to be January, February, March, April, all the way to December. Okay, so our range is any one of those months, okay, no more, no less. All right, but again, your domain is just whoever the child is, and your range is all of the months. Okay, let's take a look at example 2. So example 2. So state whether the following are functions. Okay, now we don't know by looking at it. Okay, but this right here is a linear function. Right, remember y equals mx plus b, or f of x is equal to mx plus b. Okay, this is how we're actually have it written right here. All right, so our function, all right, is a linear equation, right, or linear function, right? So what's nice about linear equations is all linear equations are functions, right? If I put x is equal to 2, right, I'm only getting one answer for that, which is 2 times 3 is 6, minus 2 is 4, right? There's no way by putting a 2 in there for x I would get anything else. So therefore, what's nice about linear functions is all linear equations are functions. And let me rewrite this up here. It's a linear equation. Okay, so all linear equations are functions, which is nice, right? So as long as you can spot a linear equation, you're good, right? And it usually takes on some form that looks like this. Now, our domain, which I'm not going to use parentheses or brackets because I want to create an interval. All right, that's hence the name, an interval notation. And as an equality, oh gosh, okay. All right, how about, I guess we could do both, why not? All right, so our domain here is going to be negative infinity to infinity, right? If we were to graph this guy, we'd see it would look something like this, right? And these arrows represent, it would go down forever towards negative infinity, and it goes up forever towards positive infinity. So our domain is negative infinity would look something like that. Okay, so there's our domain. Got to come up with the range now. We use a different color. So our range, again, what's nice about linear equations, right, is they just go on forever, right? So we are going to negative infinity. The more we go to the left, and we're going to positive infinity the more this graph goes to the right. And so our range, negative infinity, greater than or equal to x, greater than or equal to okay? So x can be any value in between negative infinity and positive infinity. That's what it means to write it in interval notation and as an inequality. All right, let's look at b. Okay, so b is also a function. If you were to plug this into your calculator, you would see a quadratic that looks very similar to this and kind of comes down and touches at -5, right? This is our y-intercept, right? Okay, so as you can see, right, if I did a vertical line test here, you'll notice I'm not touching any of my graph twice. All right, so we do have a function. Now let's talk about the domain. Now the domain, right, if you take a look at this picture here, okay, my awesome picture, right, if I drew these arrows here, right, that would signify this thing goes on forever. So even though it doesn't look like it, it's still kind of drifting to the left here, right? And this is still kind of drifting to the right. So therefore our domain, and I almost put it as a list, I don't want to put it as a list, you want it in parentheses because I want to incorporate all of these things. Our domain goes from negative infinity to infinity. All right, ooh, which reminds me, when I write it like this, I'm sorry. Let me go back here. Okay, the parentheses mean that we cannot equal infinity and negative infinity. All right, so remember when you have braces, or I'm sorry, when you have parentheses, okay, when we go to write our inequality, we got to write it such that we can never equal infinity or negative infinity. All right, so that's our domain. Hopefully you guys fixed that on the right there. And our range. All right, well, let's take a look at this. All right, our range, we want to measure from bottom to the top. All right, so as we start, this is called the pencil trick. If you take your pencil and you put it on your graph and you start moving up, right, what's the first point? What's the first y value we run into? We run into a -5. All right, now we want to include this point, so I'm going to put this in a bracket, right, because we don't have a hole there. All right, so there's -5, and then where is it going? All the way to infinity, and when you're representing infinity, you can never really touch infinity, right? So therefore, that's why we have to put it in parentheses, right? So this goes back to your inequalities, right? So if I were to write this, it would go -5 is greater than or equal to x, right? Because we can still equal -5, but we'll never equal infinity. All right, that's letter B. Letter C. Okay, so again, vertical line test, right? This is a nice one, okay? Fails, so therefore, not a function. All right, let's talk about the domain. The domain, you want to measure from left to right. So as you take the pencil trick and you kind of drift it from the left of the graph to the right, what's the first x value we see? And we run into when x is equal to 0. Now we don't have a hole there, so we want to include that point. So 0 gets a bracket around it, all right? Not a parenthesis. And then you got to remember that these lines go on forever, so which means it is heading to infinity, but we'll never reach it. And so our inequality would look something like this. 0 is less than or equal to x, but is less than infinity. Okay, now the range, okay, we're starting from the bottom to the top. So you start at the bottom. All right, what's the first thing we run into? We run into this arrow right here. And where's this arrow pointing? And it's pointing to the right, but it's also kind of pointing down, right? It's drifting down that way. So our range starts from negative infinity. And if you haven't figured out where it's going, I'm going up to the top, right? So as I push my pencil up, I run into this line here, which is pointing towards positive infinity. And again, when I go to write this as an inequality, because I have parentheses around these, because we'll never actually reach infinity. That's how you'd have to represent it. Okay? Let's look at the next one. Okay. Now, this one passes the vertical line test, right? So we're good here. So this guy is a function. Give myself some space. All right, our domain. Okay, well, what's the first value we run into when we go left to right? I run into this guy right here, which is a -4. All right, now notice I have a closed dot here, right? Which means we want to include that point. And so we're going to have a -4. And then as we go further to the right, the last point we run into is this guy, which is a -1. And so there is our interval. I'm going to rewrite it as an inequality. So because I have brackets around the 4, it's got to be greater than or less than or equal to. And then x is going to be less than or equal to 1. Okay. Now the range. All right, we start from the bottom up. All right, so as I come up from down here, right, I start at the bottom and I go this way. Okay, start at the bottom. The first y value I run into is a -2. And the last one I run into is not this value, but it's actually right up top here, right? Where does our graph stop going? And it looks like that is at 2. Now again, you don't have any holes here. I want to include both of those points. So I put a bracket around it. And if I were to write this as an inequality, it'd be -2 is less than or equal to x, which is less than or equal to 2. Just a reminder, if this had a hole in here, right? If we had a hole there, we would have to write the range like this. And then it would be written -2 is less than or equal to x, less than or equal to 2. Okay? So only if you have open holes there. All right? So this is kind of touching back on some stuff maybe you haven't seen in a while when we're talking about inequalities. Okay? But when you have a bracket around both sides, you get an inequality that looks like this. If you have parentheses on both sides, well, then you get an inequality that looks like this. And in this particular case, we got a bracket on the left and a parenthesis on the right, and so your inequality would look something like that. All right? So hopefully that's not so much review that you don't know exactly what I'm talking about, but we'll find out in class when you guys bring your questions, what you should be doing. All right, so this one, vertical line test. Okay, this is a step function. As you can see, right, when I draw a vertical line down there, we have a hole here, which means I'm only touching the graph once at those particular spots. All right? So, this is a function. And our domain. Okay, so you notice these arrows pointing way out here, which means as we come from the left, right, we run into this arrow pointing out to -infinity, and over here, this keeps pointing to the right, which is pointing to positive infinity. And so if we were to write this inequality, it would be -infinity is less than x is less than positive infinity. All right, because you can never reach infinity. There's always a bigger number. All right, our range, we start from the bottoms up. Right? So we start from the bottom, we go to the top. So the first one I run into is when y is equal to -3. Now for this one, right, I am going to put this in a bracket because, you know, even though we see a hole right there, okay, -3 is still counted for over in these pieces, right? Okay, so we're good. So we have -3, and then what's our last y value we see up here? We see y is equal to 3. So our inequality, whoops, would look like this. -3 less than or equal to x less than or equal to +3. Okay, and so to wrap things up here, you guys, all right, we're going to talk about real briefly the definition of parent functions. So these are you're going to have to memorize, all right? What they mean by parent functions is this is the most basic of this type of equation or function you can come up with. So a linear equation, the simplest one is y equals x. The most simple quadratic is y equals x squared. Okay, same thing with cubic, absolute value, okay? And so we'll discuss more about these parent functions and what that exactly entails. But for right now, just try to recognize that that's what those particular graphs look like if you were to put them into your calculator. Okay, so I know the homework looks a bit lengthy, but I don't think those problems should take you a whole lot of time. So good luck with those, you guys, and bring questions.